Okay, super simple question here. It's asking us, one moment. Okay. It's asking us the change. I can write it out. It's so easy. Um, change the kinetic energy, just change in KE, during whatever time. The time literally does not matter. Just asking for us for this, right? Um, and what we know, right, is this cute little rock is being lifted up by a certain force, and this force is greater than the weight. Um, because it's going up like this, we also know that it is accelerating because that's a check mark. Because it's moving upwards. And because it's moving upwards, because it's moving in general, it's gaining kinetic energy and also gaining gravitational potential energy because it's getting further and further. It's lifted up off of the ground. For this question, you just have to consider the work energy theorem, which just says the change in kinetic energy is equal to the work, so the net work being applied. Towards the rock, the net force is going to be F minus weight, because it's like literally saying the force that is greater magnitude than the rock's weight, W, right? So when the F is greater than the weight, it moves up. So all the force being applied, right, if up is positive, means that our upward force, which is again positive, is being weighed down by the negative force, which is the weight, which is pulling them downwards. So you just get F minus W for your FNet, and that is quite literally just answer choice A. Work done by the net force F minus W. Um, do I want to explain why other ones are incorrect? I'm trying to think. Er, I'll go into a couple of them. So, I mean, just off the bat, I know D is not correct. Um, just because it's talking about momentum. Momentum has to do with impulse, which is force times time. That has like little relationship with the change in kinetic energy. So, like, it's not going to be correct there. Um, and then a change in gravitational potential energy, that is mgh, which is the work of the height, which is not the change in kinetic energy. It's not going to be either. Um, and then the other two, the work of the weight alone would be negative work because it's just going downwards, and that's not equal to the change in K. And the same goes with the work by F alone because the work of F is only positive. We don't have a negative of the weight pulling it down. So it'd be like too big, for example, right? This is too much. This is not the correct relationship. So in the end, we're just looking for F minus W. If you just give us F, you just give us W, it's not gonna be correct. You need F minus W. Um Honestly, I don't really know how you even know this one. I just like taking a bunch of notes. Like you just have to know like changing kinetic is equal to the net force. Um, but yeah, that's basically it.